permutations or combinations. Now, because choosing between permutations and combinations can often be tricky, we provide the following example that emphasizes the difference between them. Example 6. Permutations and combinations. Corporate officers and committees. Now, the Google company must appoint 3 corporate officers: a chief executive officer, CEO, an executive chairperson, and a chief officer, COO. It must also appoint a planning committee with 3 different members. There are 8 qualified candidates, and officers can also serve on the planning committee. For part A, it says, how many different ways can the officer be appointed? Okay, so note that order is important because the officers have very different functions. Because order does count, we want the number of permutations of R, which is equal to 3 people being selected from N is equal to 8 available people. So we get the following. Okay, we know that N is equal to 8, so we're going to plug in N to be 8 into our formula. And we know that R is going to equal 3, so we're plugging in R to be 3. Okay, now recall that what we want to do is we're going to first simplify the denominator. So 8 minus 3 is going to give us 5 factorial. And then that tells us how far we should go in the numerator. So this 8 factorial can go from 8 times 7 times 6 times 5 factorial. Well, we can simplify the 5 factorial in the numerator and denominator to become 1. So what's left is 8 times 7 times 6, which is equal to 336. Okay? Because again, when we're talking about the officers, you can see that that must be in a specific order. Now in part B, it says, how many different ways can the committee be appointed? Now note that the order of selection is irrelevant because the committee members all serve the same function. And because order does not count, then we want the number of combinations of R, which is equal to 3 people selected from N is equal to 8 available people. So let's take a look at this formula. So again, we know that N is equal to 8, so we're going to replace N to be 8. And then we know the value of R, which is going to equal 3, so we're plugging in 3 in for R. Okay, so the first thing we're going to do is we're going to take 8 minus 3, and that gives us 5 factorial. And then we have 3 factorial, which expands to 3 times 2 times 1. Now in the numerator, we have 8 factorial, and we're going to go all the way to 5 factorial so we can simplify that 5 factorial in the denominator. So 8 times 7 times 6 times 5 factorial. We know that 5 factorial divided by 5 factorial is going to give us a 1. And we know that 3 times 2 gives us 6. So 6 goes into 6 one time. So what's left in the denominator is 1. And what we have left in the numerator is 8 times 7 times 1, which is the same as 8 times 7, which then gives us 56. Now, with order taken into account, we see that there are 336 different ways that the officers can be appointed. But without order taken into account, there are 56 different possible committees.